Okay, so one of the videos I made was talking about finding the function values given a graph. This one I'm talking about different domain issues. So remember the two that we talked about was we can't have a 0 in the denominator, right? We can't have it equal to 0 in the denominator, and we can't have a negative value in or under a square root. So if we have a function, this part right here, that cannot equal 0. If we have another function with a square root, whatever's under here has to be greater than or equal to 0. Alright, those are the two things that we're going to focus on. I'm going to give you a few examples for each. So if your first one looks like this, if you have something like 2x over x minus 3. Alright, so the top we don't have to worry about because if we have anything plugged in here, it makes it alright. But this part right here, we do not want this to equal 0. So you have to ask yourself what x value is going to make this bottom 0. So if you can think of it, that's great, but if not, you can set up the equation x minus 3 does not equal 0. Add 3 to both sides. So we say x does not equal 3. So for our domain, you can say x does not equal 3, or you can say all reals except x does not equal 3. Either one I'll accept. So for this problem right here, this is what gets confusing for some people. They do a lot of square roots, and then all of a sudden they say this one has to be greater than or equal to 0. You make sure and remember that this is not equal to 0. Fraction not equal to 0. Alright, now if we have a square root, if, say, we have the square root of x plus 5, this right here, this what is underneath the square root has to be greater than or equal to 0. If we make it anything else, this right here is going to be negative. Alright, so we're going to solve this the same way we solved it before. When it says equals or not equals, we just move the 5 over, so we subtract 5. And so now it's x is going to be greater than or equal to negative 5. Now if you look at this on a number line, and you have negative 5 here, you can test it to see if you're correct in saying that. If you looked at negative 6 and plugged that in, any number to the left of negative 5, you would see that that would be negative. Those do not work. So what you have to look at is you can use negative 5 and any number bigger than that. That's why we're using this notation. And if you want to use interval, you can say bracket, negative 5, infinity. Alright, but some of them are a little bit more difficult, so let's look at one of those. If we have f of x equals 2x over the square root of x minus 3, now we have two things we have to worry about. It's still on the bottom, so it can't equal 0, but it's in the under a square root, so we have to make sure it's greater than or equal to 0. It can't be both because we have not equal to and equal to right here. So the way we fix that is whatever is under here, if it's in the denominator under a square root, we say it's greater than 0. So all we have to do now is say x minus 3 greater than 0. So that means x must be greater than 3. Notice the difference between these two problems right here. This was just x minus 3. This was the square root of x minus 3. That's why we had to do a little bit extra. Alright? Now for something a little trickier. Alright, if we have f of x equals the square root of x squared minus 25. Alright, we know this has to be, or no, let me make that plus 25. X squared plus 25. We know this right here has to stay positive, right? X squared plus 25 has to be greater than or equal to 0. But the first thing you want to make sure you remember is that you cannot, these two are not equivalent if you just say the square root of x squared plus the square root of 25. That is bad. Really, really bad. Don't do it. Don't do it. Don't do it. Alright, you have to keep this plus in there. But whenever you're trying to figure out what is going to make this negative, alright, when you look at this, you're like, okay, how in the world can I make this negative? How can I make this not work? If you think, okay, what about if x equals negative 5? Well, if you plug that in, negative 5 squared plus 25. Well, negative 5 squared, that's going to give you positive 25 plus 25. Well, that's going to be a positive number. So that's fine. We can use that. Well, what about x equals negative 6? Again, negative 6 squared gives us 36, so it's going to stay positive. When you have an x squared and a plus right here, our domain is going to be all real numbers. We don't have to worry about anything. Now, if we looked at what I did the first time, x squared minus 25, that's when we have to do a little bit of detective work, a little bit of problem solving. Alright, so we have x squared minus 25 greater than or equal to 0. We still want to make sure it's greater than or equal to 0. We move it over. We have x squared greater than or equal to 25. We take the square root. Everything's great. But here's the problem. When we take the square root, we have to have plus or minus, right? So we have x is greater than or equal to plus or minus 5. Well, all of a sudden this doesn't make sense. How can it be greater than or equal to negative 5 and positive 5? So the easiest way to do this is just to look at a number line. Plot negative 5 and positive 5 and see where it works. We have 3 intervals. We have negative infinity all the way up to negative 5. We have negative 5 to positive 5, and then we have 5 to positive infinity. We have to see which one of these works. Alright, so if we checked something on this side, we have to pick a number less than negative 5. So if we checked negative 6, if we plug negative 6 in, we just did that up here, we said it's going to be positive. So this interval works. We're going to use that. If we plugged in a number in between negative 5 and 5 to check to see if it works, let's say 0. If we plugged in 0 right here, 0 minus 25, that doesn't work. That doesn't work right there. We see that it's going to be a negative number. So that does not work. And this negative 6, I'm sorry, I was looking at this one up here. If we still plug it in, we see negative 6 squared is positive 36 minus 25. Well, that's still a positive number. Alright, so that works. Then if we say positive 7, 49 minus 25, that's also going to be positive. So these two intervals are the ones that we want. Well, we want to write these out. So there's 2 ways you can do it. I'm going to write the interval notation first. So if we have negative infinity, comma, negative 6, we're going to include that point. Remember, because parentheses, we're not including it. Bracket, we are. This is just a union symbol. It just means or. It's not a big deal if you use that. Oh, I made a mistake. This is negative 5. That's really easy to do because you see this right here, but this is the point you're looking at. Alright, then you're going to do another bracket, and then it's going to be 5 to positive infinity. Alright, if you did that the other way with inequality notation, you would say x is less than or equal to negative 5, or x is greater than or equal to positive 5. Alright, remember, these are your points that you found right here. You're just checking to see which interval worked, and we found that these are the 2 that worked, that didn't, so we're just including this. So you can answer with this one or with this one. Alright, so hopefully that helped a little bit. You can pause, rewind, watch this again, or do whatever you need to do to make sure you understand this, because this is something you definitely need to know for pre-cal and calculus.